Hi guys, my name is Gabriel Voigt, and I am from Charleston, South Carolina, representing the School of Palmetto Scholars Academy. My experiment is the effect of tin whisker growth on a lead-free solder testbed, and my partner, Joe Garvey, cannot be here. Before I start off with this page, I'd like to say a basic definition of solder. Solder is there's two kinds of solder, and there's lead solder and lead-free solder. And in lead solder, it's 60% lead and 40% tin. And in lead-free solder, it is 60% tin. And there's about 40% of 5 other smaller, not as known metals. And basically what you do is you would take something and you would heat it. And then you would apply the solder, and it would connect 2 different metals that really aren't meant to be connected. So if you have a circuit board, you would solder the circuit board to ensure it would work. Now, the problems with lead-free solder are it makes tin whiskers, which is a crystalline structure that causes failures to satellites and planes, and this costs millions of dollars, and it's a very big issue in the world today. So tin whiskers do not happen with lead solder due to the fact that lead is a very heavy metal. And the reason why tin whiskers are grown on tin lead-free solder, which is basically consisted of tin, is because when basically the solder is under high pressure, it will crack. And these little, if I go back to the first slide, these little structures will come up from that, causing its own circuit, or it will connect to something else in the circuit board, causing whole shortages. Now, we are going to have a tin electroplated brass substrate, and that will be in our FME, and that is to have surface area and to see how many whiskers we can grow at a time. We will have a printed circuit board with real lead-free solder on it, and there will be polyethylene foam with slits in it to ensure that they do not move around in the FME. 1 through 4 on our materials list is what will actually be in the FME, and then 5 through 10 will be what we electroplate our metal with. Experimental preparation. Now, this is actually what our FME will look like. The black shall represent the end caps. The blue will represent the polyethylene foam, and the red will represent the tin electroplated brass substrate, and the orange will represent the printed circuit board. And this, we figured, will maximize the surface area in the FME so we get the best results possible. Data analysis. Data will come from both FMEs, and it will be analyzed after it comes back from space. The test bed will be examined with a scanning electron microscope, and we will also look under a lab microscope if they are visible enough. Now, these things can take years to grow. That's why we actually have it's kind of like a recipe, and it comes from NASA. It's a person named Ludmilla, and she has found a way to speed up the whisker growth because we can't really wait a year on this project. So it will probably happen in 2 to 3 days, is what she told us. Therefore, we can have enough time to grow this in space, and we can also still compare our results to the ground experiment. The ground truth experiment. Since our experiment was not selected for the space flight, our experiment can no longer get basically funding for the electroplating, and we couldn't get a printed circuit board from some of the places here in Charleston that can supply that. So that is what we actually came up with, which is on budget, and that is basically just the lead-free solder. We did have to cut out the printed circuit board. The Type 1 FME is now in a secure location at room temperature. We would like to thank the following partners and sponsors that helped us through this, and I would like to thank personally my mentor, Joshua Neely, who is a great man, and he spent countless hours with us, helping us and basically giving us advice and he is probably the reason why we made it this far.
Are there any questions? And while folks are coming up, I hope there are some questions here. This is a real, very important teachable moment. Let me just make a comment here. When professional researchers submit proposals against an announcement of opportunity for some precious but limited research asset, the vast majority of those proposals will not succeed. That is the way it works. And it's up to the review panels, say at NASA or NSF, to provide feedback on each proposal, strengths and weaknesses. And the Step 2 review panel that's held here at the National Air and Space Museum for all the finalists spends a great deal of time writing up in detail strengths and weaknesses. So the way that that works in the professional world is that there is guidance back to the proposing team on how they can address the failures or the deficiencies in their original proposal and resubmit against the next opportunity. That's the way it works. Kelly, I think I'm hearing that it may be that North Charleston may want to move forward with Mission 5. That's correct. So in the context of this being a very authentic program, we have two remarkable finalist teams here that potentially have the ability to repropose just like professional researchers do. So that's, this program is indeed authentic in every sense of the word.
I was just wondering about the whiskers. You said that they grow over time, and I know that you said that with circuit boards that could be a problem because it could connect to other components and it could mess up the circuit. And I was wondering, how long would it take, because you mentioned before that I believe it was an electron microscope that you needed to actually see the whiskers. How long would it take before this could actually become a problem for a circuit board?
Well, it kind of depends, but let's say you send a satellite to space, it starts with the G-force going up to space, and that will initially crack the solder and start the process. And it can happen from a various 1 year to 10 years, but since you can't bring a satellite back from space to analyze why it was breaking, this hasn't been a known problem. And yeah, so it's basically, it can happen, and it varies on some objects, but I would say 1 to 2 years for it to start.
All right, thank you very much.
Well,
hi, I'm Keith Hall from Connecticut, and my question involves some of the presentations we heard yesterday. I was wondering if you gave any thought to how you selected a polyethylene foam for your container in light of the fact that it may cause or can grow mold, and if that would have any impact on the growth of the tin whiskers.
Okay. Well, to pick the foam, we tried various foams. We even tried cutting styrofoam out of one of those cups you can buy, and we found that this one was the most secure because it was thick and it was strong. And we found it online because we wanted a strong foam, but it was easy enough to cut into the FME so we could secure both of the printed circuit board and the electroplated brass. And we didn't find that any mold could really grow on it. We looked into all options, and we're pretty sure that as long as it's dry and secure, that it would work in our situation.
Okay, let's thank Team 3 from North Charleston, South Carolina.